I'm Chris Savage, and this is Savage Circuits TV. This episode of Savage Circuits TV was brought to you by Sony Creative Software. Visit them on the web at sonycreativesoftware.com. This year I had the opportunity to attend the UPU, the Unofficial Propeller Expo West at Parallax in Rockland, California, and I met some very interesting people this year. But one person I met who I'd heard about but not really had the opportunity to talk with was Bill Henning from Micronauts. And Bill has created all kinds of products and projects using the propeller chip that I wasn't aware of. And after getting a look at his display table at the UPU event, I got thinking that maybe a lot of other people weren't aware of these products and projects either. So what I did was had Bill talk about some of his various products that he sells and some of the things he's working on. And we're going to present them here for you in this episode of Savage Circuits TV.
Hi, I'm Bill Henning, and I have a small company called Micronauts that hopefully will be big one day. I designed an architecture for a line of products over a course of about 2.5 years. Actually, now it's about 3.5 years. And last year, I introduced the first pieces of the product line. The first one was Morpheus. Morpheus is an advanced propeller single-board computer, and I'll briefly cover the features. It has two propeller chips, one of which is used to provide PS2, keyboard, mouse, stereo audio, real-time clock, EEPROM, and for running programs. It also has a programming connector compatible with the standard Parallax prop plug, and it has two sockets for DIP 8-pin SPI memory devices, be they SRAMs or flash memory. It also has a leftover expansion port P0 through P7, just like on the propeller demo board. The PS2 keyboard and mouse are propeller demo board compatible now. The unique features of Morpheus are actually tied up with the second processor that I added. The problem, I love the propeller. It's the most powerful microcontroller for most applications that I've worked with, and I've used PICs and AVRs, and I'm also dabbled with ARM-based chips. And when I first ran across it in 2006, it blew my mind that I could get a 40-pin propeller DIP, just add a crystal, a few resistors, and I could actually generate text and limited graphics on VGA, and pretty sophisticated TV graphics. Now, I really wanted more sophisticated graphics for displaying industrial HMI graphics and line drawings, bar charts, controls, because my background is actually in IT and especially industrial control. So what I did is I designed an expansion bus for the propeller, because the propeller natively does not support external parallel devices or memory. So I made a bus that is somewhat similar to the old ISA bus, with 24-bit addressing and 8 bits of data, read and write. And I added 512K of parallel memory and a memory controller on board. This allowed me to write specialized drivers for generating high-resolution bitmap VGA graphics. I also wanted to have more colors than the standard Parallax 64-color VGA circuit allows, so I used another cog and I reconfigured the DAC to have 256 colors. My first drivers were only 4 colors out of 256 per pixel, but with a separate palette on each scan line. However, I've now also implemented some drivers which provide 256 colors per pixel. I'll talk some more about demos later. On top of Morpheus, you can add expansion boards. The first standard board is called MEM+, and it provides up to 2 megabytes of additional static memory, 16 bits of parallel I/O, and a serial port propeller program. So with the combination of two boards, you can have a 2.5 megabyte propeller system with high resolution graphics, built-in serial port programming, basically everything you need in approximately 4 inches by 3 inches by 1.5 inches of space with a very low power draw. Then I added prototyping boards, one which has a propeller EEPROM and a large bust prototyping area, and also supports up to 12 servos, and one which is just a blank slate with my connectors on it for adding whatever circuits you need, either to the prototyping propeller, which is called Proteus, and the bare board is called Proteus. And you can also stack Propteuses onto Morpheus for adding additional cores and additional I/O. That was what I introduced last year. After introducing Morpheus, MEMPlus, Proteus, and Proteus, I also introduced a lower cost programming adapter, which wasn't necessarily made due to the lower cost. It was actually made that due to the industrial world still mostly using RS-232 devices. There's a huge number of devices, anything from traffic lights to scales, that use a serial port. Now, after that, I started branching out, and I'm now also carrying 7-inch 800 by 480 resolution OEM LCD displays meant to be integrated into custom equipment with an analog board that takes VGA, SVGA, and video, and also 5-inch unit at 640 by 480. Ultimately, I plan on making a portable Morpheus. This year at UQ 2010, I'm introducing a large number of products, and while I like the original Morpheus design, and while the new versions of Morpheus are 100% compatible, a friend of mine in Sweden offered to relay out the PC boards. And while I'm not ashamed of my PC board layout skills, I have to admit that Sophia, with his many years of experience in laying out PC boards, does a much nicer job than I do, and his PC boards are a work of art, and I'm delighted to have him working with me. The new Morpheus, which replaces the current Morpheus, is very similar to the current Morpheus. The only major changes are the addition of infrared input and output, so you can use a standard 38 kilohertz remote control to control Morpheus. And I also, since I was taking infrared input, I thought it'd be helpful to be able to generate 38 kilohertz infrared signals for controlling set-top boxes or anything else that has an IR remote. Morpheus Plus also adds Ethernet, compatible with Harrison's drivers for the propeller, and also has 4 sockets now instead of the original 2 for SPI flash, RAM, or FRAM. And those can be either DIP or SOIC 8 patterns. As I am going after the industrial market, I also am introducing a line of I/O modules that work with Morpheus, and also any other propeller-based board, because they use the standard 10-pin expansion connector established on Parallax's pole boards. The first module is a DC input module with opto-isolators, and it provides 8 24-volt nominal DC inputs that are optically isolated. There's also an LED indicator to indicate the state of every input. Now, the extra special sauce in these modules is that they're designed to work not only with the propeller-based boards, but they will work very well with basic stamps, SX48, or indeed any other 3.3 volt or 5 volt microcontroller. They are also designed so they would actually plug in nicely to breadboards. In addition to the standard 10-pin port, I also have 2x5 10-pin connector, so that short ribbon cables with IDC connectors can be used to connect the modules to MEMStar and my upcoming propeller logic controllers. Since I have a digital input module, I must have a digital output module. Again, the industrial standard in most plants is 24 volts DC. So this module uses 8 small solid-state relays and can switch up to 60 volts DC at up to half an amp per output. So you could, at home, if you were so inclined, you could use these to run your hobby railroad set or even some 12-volt Christmas tree lights. Since we have digital input and digital output, we also need analog input. This module provides 8 channels of 12-bit analog input and for each channel it provides a Zener diode to protect against overvoltage. It has a programmable voltage reference via a potentiometer, and it has a voltage divider, or high impedance voltage divider on each input. So theoretically, there's nothing stopping you from using this module correctly configured for input ranges from 0 to 0.1 volts or 0 to 500 volts DC. At this point, I should mention that the modules are not UL approved and they are at your own risk. However, I am using UL approved opto-isolators and relays. For my boards which have onboard A to D converters, there's a simplified analog conditioning module which has set user configurable voltage divider and Zener diode protection and some filtering and high impedance for every input. I'm afraid I can't show you my analog output modules because the PC boards were late. However, I have two different analog output modules. One of them takes advantage of the propeller's capability of generating high-speed PWM signals, and it uses a buffer chip to provide 8 channels of analog output with a 0 to 5 volt swing or 0 to 3.3 volt configurable. With the driver I'm currently working on, it should provide 10 bits of resolution at 10,000 updates per second. It is possible to get greater number of bits resolution by trading it off for a lower update rate. The other analog output module is somewhat specialized and is more intended towards motor control applications because it uses the microchip MCP4922 2-channel 12-bit DAC, which has a special feedback mode for feedback from motors. One board that has generated a lot of interest is my new FlexMem board. I'm sorry, the driver is not ready yet. It provides a 4-bit wide interface from 4 SPI-based memory devices, whether they be RAM, FRAM, or flash. And with the driver I'm working on, should provide 3.3 megabytes per second burst reads and writes with 1 cog or 6.6 megabytes per second with 2 cogs. At 6.6 megabytes per second, that's fast enough to do frame buffers for NTSC video. Another product is the new CPU module. This one was the result of discussions between myself and Sophia because my original thought was to make a surface mount module. However, he wanted something that could be plugged into a breadboard or put near a breadboard for quick experimentation. The compromise that resulted has a 3.3 volt regulator and EEPROM on the bottom, screw terminals for feeding between 4.5 to 7.5 volts to the voltage regulator, and a propeller with crystal and capacitors underneath the socket. It's a great little module and you can plug 3 of my industrial modules into it. It also has a prop plug compatible connector. I call my COM connectors HCOM, and the only difference from a prop plug connector is the addition of a 5th pin that provides 3.3 volts to the communications modules. I have 2 communication modules, the previously mentioned SIR-plug, which is a serial port programmer or easy to add additional serial port for the propeller or other microcontrollers. And I also have a matching module for RS-485 based networking. The module has an optional terminating resistor which you can enable or disable with a shunt, and it provides for easy daisy chaining by providing 2 RJ45 connectors or 2 3-pin screw terminals. If you use 6-pin RJ45 connectors, the pinout is actually Modbus standard. It uses any old Cat5 Ethernet cable for easy networking.
I'm Chris Savage, and we'll see you next time.